Good afternoon, guys. Hopefully you're enjoying your snow day at home. We're going to continue notes today with 7.4. We're day 2 now. Today we're going to be specifically referencing graphing. So make sure you've got calculators, or if you're at home, remember that Desmos.com, or there's a lot of other ones on your phone that you can also reference and use for today. But make sure you get some kind of graphing device that you can use while we're going through the notes. Now, first thing, our definition of logs. Remember, we have two different ways that we're going to see logs. You're either going to see them as a log base b of y equals x. Remember, that's how we say it, log base b of y equals x. And we can take that and we can do our circle, starting at our base to a power of x, come back across equals y, and we can write that out as an exponent. Or, remember, we can go the other direction. B is still the base over here. It's just now a base for the power. So we can start at B, and we could do log base B of y equals x. And we can go the other direction. Okay, again, in the next couple sections, we got to get good at going back and forth between those. Now, last time I made a point to say when we were doing inverses, to make sure you had that log on the left-hand side. And I'm still going to do that for consistency, okay? Depending on what kind of question, either the log needs to be on the left or the power needs to be on the left, okay? But again, that's just for consistency. So that way when I know I'm doing my circle, I'm always going to the right, okay? If the log is on the other side, as you see it down here below, the log is on the right-hand side, you still have to start at your base, but since the log's on the right, your circle is going the other direction. So b to a power of x, and then back across equals y. Okay, and I'm showing you this to make sure you understand that you can go either direction, but like I said, I'm going to stay consistent. Anytime I'm dealing with these questions, the log is always going to be on the left or the power, depending on what I'm looking at. Now, evaluating logs that are bases other than 10 or e. Okay, well, first thing, if it's an E, make sure you recognize it's an ln. An ln is a button in your calculator, so we can type it in. If it's a 10, remember it's just log of something. Remember that 10 is not really written down here on the bottom. Okay, so if we've got something other than a 10, which is our C, and we've got a number here, U. Now, if this is not a 10 or an E, you cannot type this in your calculator with that log button. So what you're going to do is you're going to have to break it up like you see here. The U is going to have to go on the top. The C, the base, is going to have to go on the bottom. And this is called our change of base formula. And you're going to see this in graphing. You're going to see this in evaluating and solving a lot of different ways. Okay, and again, the key is if this is not 10 or E. Okay, you're going to have to do this if this is not 10 or E. Now, when you're graphing, which is what we're doing today, we're also going to have to do this, okay? Again, as long as it's not a 10 or an E. If it's a 10 or E, you just use your natural log button or your log button. But if it's not a 10 or an E, so in this case, my x is up here, so log of x would be on the top, and then whatever that base is, log of C would be on the bottom. So this would actually be what we would be typing in our calculator, right here. Okay, so you cannot type. If this is not a 10, you cannot type this in your calculator. You would have to change it so you'd have a log on top, a log on bottom in order to type it in your calculator. Now, parent graphs for logs. The other day we looked at parent graphs for exponential growth and exponential decay, and these logs are going to be very similar to those. It says the graph of y equals log base b of x is shown below for b is greater than 1 and for b is between 0 and 1. Because y equals log base b of x and y equals b to the x are blank functions. Okay, well, when I come up here and look at this, the fact that we can do that circle and we can go back and forth between the two of them tells us that these are inverse functions. Then it says the graph of y equals log base b of x is the reflection of the graph y equals b to the x in the line blank. Go back a chapter when we talked about inverses. Gave you a piece of paper. We folded it, we put dots through it, we put holes through it, and we made the connection that if it's an inverse, the x and the y are always going to flip. That's why anytime we talk about inverse, those flip. And that line that we reflected on when we're graphing is that x equals y line. So I've got a couple things to recognize here. First thing is that the blue is my growth, and this one is for when b is greater than 1, so this is my growth. And this one over here is for when b is between 0 and 1, so this one would be my decay. So these are my growth and decay functions, and if I look at the blue one, we're starting out at our asymptote. Remember, our asymptote for the growth and decay went horizontally. So we started out at our asymptote and we grew up. Same thing with the blue one here. Here's my asymptote, but remember this one was a decay, it was backwards. So we started high and we came down towards our asymptote. Now, reference what we said a second ago. If we are reflecting these because they're inverses along that x equals y, and that's that dotted line going through here, everything's going to flip-flop. Everything's going to change. X's become y's. Y's become x's. So first thing I want you to reference is the asymptote. We had, with growth and decay, with a b to a power of x, we had a horizontal asymptote. So if we're doing the inverse to get the log, we're not going to have a horizontal asymptote. We're now going to have a vertical asymptote. So now with these logs, they're very similar in the shape of the function, but now it is a vertical asymptote, as you can see down here on the bottom. Same thing over here on the decay. We had a horizontal, but we're flip-flopping everything, x's and y's. So now as you can see up here on the graph, it is a vertical asymptote going up and down. And if you reference the points that they put on the graph for us, 0, 1 became 1, 0. 0, 1 became 1, 0. Okay, so our graphs themselves are very similar, but our horizontal asymptote's now vertical. And now let's reference the shape. This first one on the left is a growth. So it starts at the asymptote, same as what we did over here. Starts at the asymptote and it grows. That's what we had for the growth. Same thing here. We start down here at the asymptote and we are growing away from the asymptote, up and away. Decay, we started up high and we came down towards that asymptote, horizontal asymptote. So on this one, we're starting at the asymptote and we're decaying down and away. Okay, so the direction still matches the saying. First one's a growth, so I'm growing up and over. Second one's a decay, so I'm decaying down and over. Okay, and again, reference that the axis is now changed. It's no longer a horizontal asymptote. It is now a vertical asymptote. Now, since that has changed, let's make sure we reference what's going to change on the equation. We said Hoylux was our saying. And we said last time that since we had horizontal asymptotes, that's why we looked at that y, and it was a y equals, and that's why we referenced the k, because that k was our up, down. That was our y. Well, if we just flip-flopped everything, and now we have vertical asymptotes, now what are we going to reference? We're not referencing our y if it's a vertical asymptote. If it's a vertical asymptote, we're referencing our x. So the k is no longer what we're going to reference for the asymptote when we're looking at logs. It's now the h. The h is the x. It's our left and right. So when I'm talking about asymptote, I'm now talking about x. So that's my h. Domain and range have now flip-flopped. So domain used to be negative to and positive infinity. Now range is negative to a positive infinity. The domain is the one that has the restriction. And then same thing. This has not changed. If that base right here is greater than 1, it's a growth. If it's between 0 and 1, it's a decay. Okay, so if it's greater than 1, it's a growth, it's opening up. If it's between 0 and 1, it's a decay, it's opening down. We're showing the same things. We're showing the asymptote, but this time, since we're flip-flopping everything, we're not showing the y-intercept. We're going to be showing the x-intercept. Okay, and again, same concept as before. If I'm looking for the x-intercept, I don't care where I'm at. If I'm looking for the x-intercept, what has to be 0, no matter where I'm at along this x-intercept, along this x-axis. If I'm looking for an x-intercept, the same thing is true for every single intercept. X-intercepts, y is always 0. Exact opposite of what we did the other day. Now, writing this in our calculator, or if you're using your phone, or if you're using a program online, that's not going to change. You still have to be careful of how you type it in. Okay, and this is a key slide because if you don't type it in correctly, it's not going to help you out. Okay, so this first thing you need to notice is this is not a 10. Okay, if it was a 10, remember, it would look like this one. There'd be nothing there. Okay, so on this one, since it's a 10, we could just type it in. But on this one, since this is a 2, since this is not a 10, we have to do that change of base. And so since we have to do that change of base, that's how we have to type it in our calculator. That's the whole point of this. Okay, so when we go to type this in our calculator, since that is a 2, I have to do change of base. So how am I going to type this? Log of what on top, log of what on bottom. And then where does that 4 go? Does that 4 truly belong with the log, or is it on the outside? That's the second thing you got to think of. Okay, so log of, which one goes on top? Log of x, and then your base is on bottom, over log of 2. And then to answer that second question, the 4 goes on the outside. So typing it in your calculator, this is how you would type it in. Log of x on top, log of 2 on the bottom, plus 4 on the outside. Second one, we have an ln button, so we just type it straight in. My bad, sorry. We just type it straight in since it's a natural log. So it's just natural log of x plus 6. Nothing's different on that one. Okay, you have an ln button, so you just type it straight in. Then, the next one, log. Remember we said again that this is a base 10. So since it's a base 10, I can go ahead and just type it straight in. Now, the one thing you got to make sure you're careful of is this 3 does not belong with that log. It's on the outside. Okay, but on the one before, the 6 belonged with the natural log. That's why they both had to be in parentheses. But on this one, it's just the x. So the x belongs in parentheses. The 3 belongs on the outside. Next one, very similar. Does this 3 belong with it, or does it belong on the outside? Well, it belongs on the outside. So it's just natural log of x, negative 3 on the outside. Next one, this is a 10. So we can just go ahead and type it in. There's nothing written here. The x and the 5 belong together with that log, so we got to make sure that's the way we type it in parentheses, x minus 5. Then the last one, a little bit trickier. This is not 10, so first thing we should recognize is we have to do change of base, and log of 3 has to be on the bottom. Log of x minus 2, since it's in parentheses, goes on top. Log of 3 on the bottom. This plus 1 is just out here on the outside. Okay, so this slide is key in recognizing how we're going to type these in, because if we can't type them in correctly, we're not going to be able to get the right answer. Now, let's do some graphing with our logs. Same concept as the other day, but be careful how you're typing them in. First one, y equals log base 1/2 of x plus 4. First thing we got to recognize, this is not a 10, so we're going to have to do our change of base. So what did we just talk about? What's going to go on top? Log of x divided by log of 1/2, and that 4, does it belong with the x or is it on the outside? That 4 belongs on the outside. Okay, so this is what we should be typing in our calculator. Now, next thing. Remember, just like before with growth and decay, always, even before you type it in your calculator, start with your asymptote and your intercept, and then make sure those two things match your calculator. Okay, so this one, asymptote, we said it is no longer RK, because that was when it was a hoi, that was when it was a horizontal. Now we're dealing with the vertical. So if I rewrite this with an X, and then is there anything inside of these parentheses? Where's that 4? That 4 is on the outside. So if I rewrite these with parentheses, is there anything here? There's nothing there. So my asymptote right here, my x would be x equals 0. So that's my vertical asymptote for this one. Again, remember, since it's log, we're looking for that vertical asymptote, which is our x. So right there. So that's 0. X-intercept, okay, again, key concept. Since it's x-intercept, that is when y equals 0. So that's what we're plugging in. So let's look at what we have right here. I need to plug in 0 for y. Now, in order to solve this, I'm going to have to do my circle. But again, I want the log on the left-hand side to keep things consistent. So I'm going to put the log base 1/2 of x plus 4 on the left and the 0 on the right. That way, when I do my circle, I don't mess things up. Now, before I can do my circle, same thing as always, I got to isolate. So I got to move that 4 over. So log base 1/2 of x equals -4. Now let's do my circle. 1/2 to a power of -4, come back across, equals x. Okay, again, that's going from our log to our exponents. That way we can solve for this x inside here. 1/2 to a power of -4 equals x. Okay, well, if you don't know how to do this without your calculator, type it in if you haven't already. 1/2 to a power of -4. Without a calculator, that's a negative power. So I could flip-flop what's inside of the parentheses. It'd be 2 to the 4th. 2 to the 4th equals 16. Okay, but again, if you don't remember how to do that without your calculator, go ahead and type it in one step before. So my x-intercept, x is 16 when y was 0. Okay, now take these two, graph it, and see if those two match your graph. And remember, when you're graphing it, you're typing actually in what's in yellow up here. Remember, you have to do that change of base in order to type it in your calculator. So you're typing in y equals log of x divided by log of 1/2 with a +4 on the outside. Hopefully you get something similar to this. Now, recognizing and seeing if the two things that we've already pointed out match our graph. X equals 0. X equals 0 is a vux, hence, again, our vertical line. So I have a vertical asymptote, dotted line, at x equals 0. That's my asymptote. Now, I can't see it on my graph, but does this 16 as an x-intercept make sense? Look at the shape of my graph, look at the direction it's going, and think about the concept. It would end up right outside my graph, which would be at about 15, 16. So that x equals 16 makes sense for the picture that I got. And if you want to make sure, you can always change your window. Okay, change your window so that you can see the outside of that graph. Now, domain and range. Again, think about the concept of asymptote. Gets close to, but never crosses. So domain is my x's, range is my y's. So x's, when I think about my x's, is there anything over here on the left? My asymptote's going up and down now at 0. So there's nothing over here on the left because I can't cross that asymptote. So where x-wise does my graph start? It starts right here at my asymptote. So it starts at 0, and then it's going to continue going to the right. So my domain is 0 to positive infinity. Range, my y's. Asymptote, this is going to keep going up. It's going to keep trying to get to 0, but it's going to keep going up. It's never going to stop. And that's one thing, depending on what calculator you have, you need to make sure you recognize this line never stops. On your calculator, it might have a little dot. It might actually look like it stops. You need to be able to recognize it does not. This keeps going up, and it goes almost straight up on that 0 axis. And then, as I come across here, I'm going to slowly keep going down. Remember, I don't have a horizontal asymptote this time. So this line will cross that x-axis, and it will keep going down. So my range is -infinity to positive infinity. Now, one last thing to make sure we see something else. If I go back up here to the top, my b was 1/2. So when I look at my picture, since that is less than 1, I should have a decay. And look at your picture. I start high, decaying down. Okay, so those two still match. So making sure that you recognize all the similarities and all the commonalities between the equation and the graph. Now the second one, the last one, y equals log base 3 of x minus 2. Okay, several things. How do we type it in? Well, first, this is not a 10, so we have to do change of base. So log of something on top, log of something on bottom. This is in parentheses, so it's got to stay together. And is there anything out here on the outside? Nope. So it's just log of x minus 2 over log of 3. And then there's nothing out there on the outside. So this is how we're going to type it in our calculator. So go ahead and do that while I keep talking. Log of x minus 2 over log of 3. Now, asymptote and x-intercept. Again, I'm going to actually do these two before I pull up my picture. Asymptote, remember, it's no longer this y. It's no longer y, horizontal. It is now vertical. So my asymptote is now inside here. But anytime, I don't care if we're talking about shifts or asymptotes, anytime we reference this x, we got to remember it's always backwards. So my asymptote is not negative 2. My asymptote is positive 2. X equals 2. X-intercept again, where is y equal to 0? So plug it in. That's 0. I'm going to flip-flop these again to make sure I have consistency with my log on the left. So log base 3 of x minus 2 equals 0. I cannot pull this 2 to the other side because there's parentheses here. So there's nothing on the outside for me to pull over because I can't touch that 2 yet. So since I can't get inside these parentheses, I got to do my circle. 3 to a power of 0 equals x minus 2. Now that I've gotten inside of here and I got rid of the log by doing my circle, now changed it into exponents, now I can solve. 3 to a power of 0. Remember, anything to a power of 0 is 1. So 1 equals x minus 2. Last step is to add 2, so x equals 3. So my intercept, x is 3 when y was 0. Okay, again, make sure you graph it. And let's make sure our graph matches those two that we just wrote down, the asymptote and the x-intercept. So we should have an asymptote at 2 and an x-intercept at 3. Now again, be careful with your picture. I used an online program, so my picture looks nice and clean. Okay, your asymptote's at 2, so that's our dotted line. Remember, that's where it looks like it disappears to. And on your picture, on your graph, on the calculator, it may look like there's nothing down here, and it may actually stop. But you have to recognize, again, smarter than your calculator, this line never stops. It's going to keep going basically straight down. Even if your calculator shows it stopping right about here, you got to know it keeps going. Okay, it's leveling off. That's why your calculator can't show it, but it keeps going straight down. And then if I look at my intercept, I can see we were correct. That's an intercept at 3, 0. Now, next thing I want to reference before I even do domain and range, my base, come back up here, was a 3. So when I think about that, that is greater than 1. So this should be a growth. We'll look at our picture. We start low, we go high. So that is a growth. Domain, again, x's, range y's. So when I look at my graph, there's nothing over here on the left. Okay, so where do I start? As I start scrolling over, scrolling over, scrolling over, I start at 2 or 3. Can I go left of 3? Yes. I go left of 3, but where do I stop going left? At the asymptote. I'm never going to cross that asymptote. So the lowest x that we have is 2, and we keep going right to positive infinity. So 2 to positive infinity. My range, again, being smarter in your calculator, it does not stop right here. This actually keeps going down. So negative infinity, and this one's going to slowly keep going up to positive infinity. So very similar to what we did the other day with exponential growth and decay, but now we're dealing with logs. So remember, since powers and logs are inverses, everything is flip-flopped. For those of you who are gone, here is your homework. Make sure you recognize on practice C, those last couple questions are word questions. And here down in red, I have circled what the actual equation is. It's kind of hard to see it on there, but the equation for that question is 67.99 minus 5.82 natural log of t. That entire thing is your equation for that question. Okay, make sure you're doing the same thing. Asymptote, x-intercept, domain, and range. And I will see you guys tomorrow in class.